Hello dears, welcome back to a new video. In today's video, we are going to see the just recalling of your unit 1 solubility of drugs. Okay, so first the code, the definition, solubility. Solubility is defined as the maximum amount of solute or drug that dissolves in a solvent at a given temperature. So comes to the expressions of the solubility, we have normality, molality and percentage solution. Okay. This is the first part of the solubility of drugs. Then comes for the solute-solvent interactions. So solubility depends on some forces like hydrogen bonding, dipole interactions, van der Waals force. Here the rule you have to remember. The rule is like dissolves like. That means the polar solute will dissolve only in the polar solvents and non-polar solute will dissolve in the non-polar solvents. Okay. That's all. Then comes to the ideal solubility parameter. So the ideal solubility parameter can be solubility can be predicted using the solubility parameter that is represented by delta. So similar delta values means we will get the better solubility. So there you have to remember Hilbrand solubility parameter as well as Henson solubility parameter. Okay. Next comes for the solvation. Solvation means your solvent molecules will surround the solute molecules. That process will called as solvation. What? Solvent molecules surround the solute molecules. Next, what is association? Solute molecules will combine together. That will reduces the solubility. Solvation will enhance the solubility, but association, if the solute molecules combine together means it will reduce the solubility. Next comes to the factors affecting or factors influencing solubility of drugs. This is 5 marks as well as 10 mark question. So you have to study in detail. Okay. So the first one is temperature. Temperature means in the case of solids, the solubility will increases with the increasing temperature. But in the cases of gases, solubility will decreases with increasing temperature. Next comes to the pH and ionization. Weak acids dissolve more in basic pH and weak bases dissolve more in acidic pH. Okay. Next, if the particle size is smaller size, we will get the faster dissolution. Then co-solvency, surfactants, common ion effect, molecular structure. Okay. So you just watch the detailed video because it is very important for your 10 mark section. Next, we will go for the diffusion principle in biological system. So in the diffusion principle, you have to remember what is diffusion. It is the movement of your drug molecule from the higher concentrations to the lower concentration. So drug absorption occurs by diffusion. So you have to remember Fick's first law there, dq by dt is equal to dA into C1 minus C2 by H. If higher the concentration gradient, we can tell faster the diffusion. Okay. Next comes to the solubility of gases in liquids. Gases dissolve depends upon the pressure. Then you have to remember the Henry's law. As per Henry's law, we can tell solubility is proportional to the pressure. For example, carbon dioxide which is dissolved in soft drinks. Okay. So higher the pressure, more gas solubility will get. Okay. So Henry's law is 2 mark important. Okay, and it may come solubility of gases in liquids factors. In that factors case, you have to remember the pressure case as well as the special case that in the case of gases, solubility will decreases with increasing temperature. Okay, the other factors are same. Like polar gases will dissolve in the polar solvents like that. Okay, next comes to the solubility of liquids in liquids. Solubility of liquids in liquids. Both liquids is there, right? So we'll call it as a binary solution. Two liquids when it is mixed together, we'll call it as a binary solution. Okay. So here you have to remember ideal solutions. What is real solutions? Ideal solutions means which is obeying the Rolle's law. That means P is equal to X into P naught. So X is the mole fraction. You can give the example of benzene and toluene. Next comes to the real solutions. It is deviate from the Rolle's law, due to the strong or weak interactions present. Next comes to the partial miscible liquids and critical solution temperature. We have completely miscible solutions, liquids, and partially miscible, right? And immiscible liquids. So partially miscible liquids is important. When we will mix the liquids, it won't mix completely and it won't show the immiscible nature. It was like a partially it will get dissolved. That liquids will called as partially miscible liquids. Okay. So like example, you can give phenol and water. That will exhibit a property, that is CST, critical solution temperature. Critical solution temperature is important for 5 mark, as well as partially miscible liquids also is important for 5 marks. Okay. Next comes to the CST, temperature at which two liquids become completely miscible. The temperature at which the two liquids will become completely miscible. The partially miscible liquids will become completely miscible state, that will be called as critical solution temperature or consolute temperature. Okay. So we have two types basically, upper critical solution temperature. In the case of above this, complete miscibility will get, above this temperature will get the complete miscibility. You can give the example of phenol water system. Okay. Next comes to the lower CST. In that case, below this temperature, complete miscibility will get. You can give the example of triethanolamine and water. Next, one special case is there, it will exhibit both UCST as well as LCST, that is nicotine and water. Next comes for the application, purification, solvent selection and formulation studies. Okay, this video also is there. The unit 1 full detailed video of each topic till lecture 1 to lecture 8 is there. You please go to my channel and just see. Okay, if you're having any doubt, the detailed explanation is already given. Next comes for the distribution law. This is also a 5 marks question, is very important. Okay, distribution law or partition coefficient law or nurse distribution law. Okay, this three will call when a solute distribute between two immiscible solvents. We can tell KD, that is what distribution coefficient, partition coefficient is equal to C1 by C2, where the C1 is the concentration of the solvent A and the C2 is the concentration of solvent B. Okay. Next comes to the application of distribution law. Is like drug extraction, partition coefficient, absorption prediction are the application of the distribution law. Then what is the limitations of distribution law? Where it will, so where the law will fail. Like fails when solute will associate, dissociate, or if it is reacts chemically, or if any temperature changes occur, the law will fail. Okay, that's the limitations of your distribution law. Okay, this is the just recap. Okay, you can see in detail in my all video lectures. Okay, I hope you people like. So bye. We will see in next unit in the next video. Bye.